Hi guys, hope you are doing well. My name is Zach, and today we are going to look at the solar panel specifications. We have taken a sample panel from a company called Jinko. Now, among the panel specification we are going to look at is the maximum power, Pmax, power tolerance, maximum power voltage, maximum power current, open circuit voltage, that is what is indicated as VOC, short circuit current, ISC, and nominal operating cell temperature. Now, to come up with these specifications, a panel need to be tested under specific conditions. And normally, a panel is written at the back plate on which conditions it was tested at. Now, the standard test conditions, this is a set of criteria that a solar panel is tested at. Since current and voltage change based on temperature and intensity of light, among other criteria, all solar panels are tested to the same standard conditions, and these conditions means that the cells have to be at a specific temperature, which is about 25 degrees centigrade or 77 degrees Fahrenheit, and light intensity of about 1000 watts per square meter, which is basically the sun at noon, and the atmospheric intensity needs to be 1.5. Now let's go straight to these conditions. One is Pmax, that is the maximum power. Maximum power point indicated by Pmax is the sweet spot of the solar panel power output, where the combination of the volts and amps results in the highest wattage. A smart charge controller, like an Impp charge controller, normally measures the solar panel voltage under varying loads and then adjusts the solar panel input circuit to balance the volts and amps and maximizes the power output during the bulk charge mode. The wattage that a solar panel is listed as Pmax is got by multiplying the voltage at maximum power and the current at maximum power at the standard test conditions. Next, if we have what we call power tolerance, which gives us how far the power can vary from the nominal power of the solar panel. Maximum power current, indicated by Impp, is the current in amps when the power output is the greatest. This is the actual amperage you want to see when a solar panel is connected to an Mpp charge controller under standard test conditions in bulk charge mode. The actual current varies with the sun strength of the panel. It is important to note that the current that a BWM charge controller will receive is slightly higher than the maximum power current under standard test conditions. Let's look at the open circuit voltage, a very important specification when doing various designs. An open circuit voltage, that is the VOC, is the maximum voltage that a solar panel can produce with no load on it. It's normally measured with a multimeter across the open ends of the wires attached to the panel. If two or more panels are wired in series, it would be the VOC of panel 1 plus the VOC of panel 2 plus the VOC of panel 3, etc. etc. While when the panels are connected in parallel, it's a different case, which we shall discuss later when doing designs. The voltage is generally highest in the mid-morning as the sun rises and when the temperatures are low. The VOC plus approximately 3.5% must be less than the maximum solar voltage permitted by the solar charge controller. If you exceed this, some charge controllers will shut down, while others may continue to operate, but the lifespan of that charge controller will be compromised, or it may result to an immediate destruction of the device. So the VOC is very important when we are designing charge controllers, a factor we shall consider later when we are discussing design and charge controllers. Let's look at the short circuit current, what is indicated on the back plate as ISC. This is the current that flows out of the panel when the positive and the negative leads are shorted together. This does not harm the panel, but care should be taken to avoid arcing. And this current can be measured by passing the current through a multimeter that is configured to measure amps. The short circuit current plus 20% is what is recommended and required to determine the handling capacity of a charge controller. This is the highest current the panels will produce under standard conditions. Note that under a clear sky at midday and by tilting the solar panel towards the sun, you could get significantly more current. The last specification we shall look at is the normal cell operating temperature, indicated as NOCT. This provides the ratings that are lower but are more realistic. So instead of using the conditions like 1000 watts per meter square, it uses 800 watts per meter square, which is closer to a reasonably sunny day with scattered clouds. It uses an air temperature of 20 degrees centigrade instead of a solar cell temperature, that is of 25, and it takes into account a breeze of about 1 meter per second that cools the back of a tilted solar panel. This is more applicable to a conventional glass and aluminum framed panel mounted on a building, or ground array but not lightweight panel that is laid horizontally, which is obviously hotter. Now, could you wish to support this program or these teachings? Kindly contact us by the details indicated below. Thank you. Have a good day.